Hi Zach, welcome to lesson number 116, and we are going to burn through this really quickly, okay? We are going to talk about the quotient rule for square roots, okay? And here we go. Let's start out with this. An opinion without 3.14159 is just an onion. Do you get it? Do you get it? Because if you take out pi, it's onion. Get it? All right, tell me if you don't get it. All right, here we go. Now, we're going to first remind you of the product rule for square roots. The product rule for square roots means that if you're multiplying two things together and they're both under that radicand sign, so it's 3 times 2 underneath that square root sign, it's the same as if you take the square root of 3 times the square root of 2. Okay? So easy peasy, you can substitute this for this. Or vice versa, if they give you this, you could change it to this. Yeah, you could. Easy peasy. Those things are equivalent. Now, there's also a quotient rule. There's a quotient rule for square roots. And remember, quotient is just a fraction. It's just a fraction. You've got a numerator, you've got a denominator. That means you have a quotient, and that means you have a quotient rule when there are square roots. So if you start out with something like this, the square root of 3 over 2, you can do the same thing, just like the product rule. You can do square root 3 is divided by square root 2. Cool. So you can divide that up. You can change this to this and vice versa because those things are equal. That is called the quotient rule for square roots. Okay, now, a lot of people, when they see this kind of thing, this is very unsatisfying. We don't like to have these irrational numbers on the denominator. So remember that you can multiply anything by 1 and you're not going to change the value of that fraction. If you multiply anything, any number by 1, you're not going to change the value of that. So in this situation, you can take the square root 3 over the square root 2, and then you look at that and you're like, I don't like this square root 2 on the bottom. It's super unsatisfying because that's an irrational number. We don't like irrational numbers on the bottom. So what you can do is you can take square root 3 over square root 2, this is what you're starting with, multiply it by 1, and it stays exactly the same, but we haven't changed anything, right? Not yet. Okay, what if you multiply it by square root 2 over square root 2? That is the same as multiplying it by 1. But what can you do now? Well, now this is what's really cool about this. Let me move that over so I give myself a little bit more space. Is when you multiply that out, and you remember that when you're multiplying fractions, you just multiply straight across. You don't have to get a common denominator, right? So you do square root 3 times square root 2, multiply that straight across, and you are going to get the square root of 6. 3 times 2 is 6. Now on the bottom, what do you get? If you have square root 2 times square root 2 here, you just get 2, right? Because it's kind of like turning one of these into, let me get a red so you can see it better. Turning one of these into squared. It's like squaring it. You're multiplying it by itself. Square root 2 times square root 2 is just 2. You probably knew that already. This on the top, you could have also written it as, drawn out like square root 3, square root 2, but as you know, that is also the same as square root of 3 times 2, which is 6. So that's how we ended up with this number. And the nice thing about this number is it's super satisfying for mathematicians because now you have a 2 on the bottom. You don't have an irrational number on the bottom. So remember, don't you think you guys should stop fighting? You're both being irrational. So remember what an irrational number is. It's this, it's these group of numbers. They're real numbers, but it's things like pi, square root 10, square root 2, square root 3, a decimal that goes on forever. Those are the irrational numbers. Anything that ends like that, you don't want it in the denominator. And when you take something that it has an irrational number in the denominator and change it into something that's no longer irrational, that means that what you're doing is you are rationalizing the denominator. Rationalizing the denominator. Okay, she's like, how do I do that? Rationalizing the denominator just makes sure that you don't have an irrational number in the denominator. You want it to be as satisfying as possible for your math teacher. So you want to rationalize the denominator. How do you know if what you are getting for your answer is in the simplified form? So this is what they say about that. An expression that has square roots, you're going to know when it's in the simplified form if no square roots are in the denominator. Okay, so you've taken all the square roots out of the denominator, and no radicand, so anything under the radicand, nothing there has a factor that's a perfect square. So for example, you don't want to do square root of 100 because that factor, that thing under the radicand sign, is a perfect square. You could just simplify that to 25, or right? 10, no, it would be, sorry, it would be 10, right? Because it's 10 times 10. Anyway, so that's how you know it's in the most simplified form. You have no square roots in the denominator and no radicand that has a factor that is in a perfect square, like the number 100 or something like that, right? Okay, so let's move on. We're just going to move on to some examples. I know you're super excited about that. Okay. Let's do example 116. Okay. So here's the thing that you have to simplify. They give you this, and then they say put it in the most simplified form. So first, you know that you can use the quotient rule, right? Okay, so this is going to be the same as square root 5 over square root 3. But that's not in its most simplified form because this is not satisfying to have. You want to get rid of that radical sign that's in the denominator. So in order to do that, we're going to multiply it by basically 1, because when you multiply it by 1, you don't change it. But in this case, 1 is going to be the fraction square root 3 over square root 3. Now, what can you do? You can multiply this straight across. So we're going to do square root 5 times square root 3 is going to be square root of 5 times 3, or I'm just going to simplify it even further and just put 15 on the top, okay? And of course, on the bottom, when we do square root 3 times square root 3, that's like having a square root 3 quantity squared. So it's just 3. So let's put a 3 there. And guess what? Easy peasy. That is the most simplified form that it can be. And it satisfies, there's no irrational number in the denominator, and there's no radicand that has a perfect square. Okay, so we know we finished. All right, let's do another one. Oh, I'm not a monster. I'm just letting you practice this. It's so fun. All right, let's do this one. 4 plus square root 3 over square root 2. This looks a little bit more difficult, but it's really not all that bad. Because what we're going to do, I'm not just going to erase it. I'm just going to grab it, move it to the side. Okay, so we need to get rid of this square root 2 on the bottom because that is super unsatisfying. So what are we going to do? We're going to multiply this whole thing by 1. Also, square root 2 over square root 2, that's basically 1, right? So if we multiply the top square straight across, you have to remember that this is kind of like in parentheses. So you have to multiply this times this, and once you've done that, you have to multiply this times this, because it's kind of like this is in parentheses, right? So what we're going to get on the top is now going to be 4 times square root 2 plus, then the next part is square root 2 times square root 3. 3 times 2 is 6, so it's just going to be square root 6 on the top. So there's the numerator, easy peasy. Now, when you multiply square root 2 times square root 2, that's the same as square root 2 squared, which is just 2. Okay, and okay, when you look at this, you're going to be like, I was asked to simplify, and now this answer that I got looks more complicated than this stupid thing that they gave me in the first place. But this form is preferred because there's no radical sign in the denominator. That's the only reason why. So this is actually the preferred way. All right, let's look at the next one. No, wake up. I know. I'm getting you excited for Jim Gaffigan when we go in December. All right, 116.3. We're going to simplify this expression. All right, let's just move this guy. Oh, let's try that again. Let's just move. I'm not doing very good here. Let's do this. How about this? Let's just move this guy so that I have a little bit more space. Okay, and now what do we need to do? Well, we definitely need to get rid of this square root 5 on the bottom. So let's multiply the whole thing by 1, which is square root 5 over square root 5. And what do we get? We're going to get, remember, you have to do this times this whole thing. Okay, so I'm just going to actually do that so it reminds me. So what we get is 2 times square root 5 plus square root 5 times square root 15. So 15 times 5 is going to be 75, and I can just write it like that with the radicand over the whole thing. And on the bottom, now we have 5 because we have multiplied this times this. Okay, now is there anything else that we can do to simplify this? Yes, actually we can, because we've got this guy right here. We can simplify this a little further because there is a factor. If you factor 75, you're going to get 25 times 3, right? And this number is a perfect square. So if that's a perfect square, we can factor that out. So by factoring that out, we would get 5 times square root 3 instead of that square root 75. So let's write it like that. So I'm just going to rewrite the rest of the problem. 2 square root 5 plus. Now instead of this square root 75, I'm going to change it to 5 times square root 3. Tell me if you don't understand that. And the denominator stays the same, and it's just 5. Easy peasy. That is the whole thing. All right. Now, one last one. Oh, no, that is the last one. Was that the last one? Yes, it was. Oh, we're done. Oh, that seemed fast. All right. Bears beats Battlestar Galactica. I hope you have a great day, Zach. Love ya. Bye.